Hey guys, so what we're gonna do is the focus is from the very beginning how to make it easier to convert into transform our imaginations into code, right? You have an idea of data types, you have an idea of for loop, while loop, conditions, API, application programming interface is nothing but just another function. It's just that somebody else provided for you. So when you call a string function, let's suppose string.capitalize or an insert function on a list, metaphorically you can say that this insert function is actually an API. Usually APIs are provided by on the HTTP on the web, right? We call Google APIs and that's how we get our transformation, and then we go ahead. You just imagine, like, we are devising ways to make this whole coding idea easier, right? So for example, this is your function, or let me just do something right like this. Now a function is something, it gets an input and it spits out or returns an output. Get something, output something, input something, output something. That's the concept of mathematical function. F of x is equal to an equation, x plus 1 or x squared or something. You get the value, right? So now this is our function. The program enters here. The moment you call this function in a compiler, you called it, right? You called it. The program enters here. So this is point 1, line 1, right? This is line 1. Here, well, you might have initiated a variable or anything, right? Those are going to be implemented. In line 1, you initiated a variable. In line 2, you initiated a variable, right? Now in line 3, this function might also have an input, right? So here is the input of the function. This function might also get an input. You in line 3, right, you might have a loop, which we are going to signify by a constant circle like this, right? A loop. And loop, so see, the moment we come in here, this is in the memory now, this is in the memory now, we come in here, this is in the memory, right? Metaphorically think, now this line, the compiler touches here, comes to the for loop, value of I is generated, and that's where we get inside this block. This is totally outside. You can think of it as 3.1 line. Think of it metaphorically in this way, right? And now here you can again think that this is a separate area where you can initiate a variable, you can initiate a list, you can act on an input, you can do your calculation, do whatever. I'm very sure that you understand these concepts of looping and all this thing. So once this is done, what happens is the program comes to line 4, right? The program comes to line 4, and then whatever is calculated here, whatever is calculated, see, this is totally independent now. Whatever is calculated here will propel to the next line, will have an access to this changes in here. If you have initiated a list in here and then input values in here into this list after a certain calculation, here we will have access to the updated list or an access to the updated value or any calculation. And then you go ahead, you have an if condition. If condition has this place, you can initiate a for, you can initiate a while, you can do any sort of calculation, whatever you want to do depending on your stuff. Like for example, you say, let's initiate the array, let's initiate the list, and then we're going to find certain value. Good, we found that value. Now I want to do certain condition. If something is true, do like this. If something is false, do like this. That's how you build logic, right? You get if condition, if the second value is this, if the result is less than this, if this and that, whatever, right? Now in this if condition you might even call an API. Now outside APIs are our external functions, right? Here you have an API. You might call this API in here. This API might just be called in here. You take a help of external functions, you make certain calculation, you get the return value and pass it to the next line. This is line 5, right? Then here you can you can do something else as well. Maybe you design your algorithm in a way that you say, well, I'm going to iterate the list, do my stuff, get my resulting value however your algorithm is, and then you say, I'm not going to let the function go ahead, I'm just going to have a return value in here based on your own thinking, and then that's it. The function just stops in here, returns a value to whoever is calling it, and that's all, right? Or in every block you can have a return statement. Even here you can check, and well, I say, well, if the return value didn't come in here, I'm going to come to the line 5, initiate certain condition, and then call an API, pass in this list. If I got a certain value, I might just return in here, right? Return basically means just return the function, done. And else, now you say, well, if this return didn't happen, and if this return didn't happen, what I'm going to do is, here, the function must return something, right? I'm just going to return just a false value. You see? Very easy. You can call as many APIs. This is another API. You can call it in this block. This is another API. You can call it in here, in even at first do a calculation on the input values, right? And then you keep thinking, you start thinking about these ideas, you keep plugging, but you think line by line. Even metaphorically, you can say, you need to think in bits and pieces. You need to think agile. And that's how the more you keep writing it line by line, the more it's gonna keep building. You start with the first line. Don't worry what's gonna happen. Just start with the first line, go to the second line, keep building your logic step by step. Go to line 3, go to this, I told you. Now this is, metaphorically you can think, whatever is happening in here is totally independent. For every line of for loop, this will initiate times and again. If you have initiated a list and you did certain conditions on it, for example, just imagine, this list will again be initiated, it will be empty. If your conditions are met, it will return it, even the loop will not start. For example, I is equal to 1, I is equal to 0, I is equal to 5, the condition is met, your algorithm, the way you have thought about it, is good, you can return a value. That's it. Algorithm will stop, the machine will stop it. And then, if not, it's going to come in here. It's going to come to the step 4. Step 4, you have done certain things, right? And then step 5, you have an if condition, you call an API, you call, for example, you call another API in here in 5.1, 5.2, you call, for example, another API in here, do certain calculation, put your conditions, make sure that you are thinking about all edge cases, then return a value. If not, you tell them, okay, we didn't succeed till here. Now the thing is just to let the caller, whoever is calling it, or you may be calling this function another way, you design that well. Now the next value might be a false value. And that's how you design and start thinking about transforming imagination into code, transforming your ideas into code. And this is one of the essence of programming. And the other thing is, the reason I'm not going directly into code is because of this. Let's just keep discussing, keep putting ideas, and then things will be good. Thanks.